Re regarding our speaker, it is with great pleasure to welcome Professor Giorgio Locatelli, talking about modularizing mega projects for replicability, the case of small modular reactors. Gio is a full professor of complex projects business at Politecnico di Milano School of Management in Italy. He has been educated in Politecnico di Milano and has a bachelor and a master's degree in mechanical engineering and a PhD in engineering management. He has attracted more than £1 million of research funds. He also works as a consultant and a visiting academic for several public and private organizations. He has authored more than 100 international peer-reviewed publications, and he sits in the editorial boards of International Journal of Project Management, of Project Management Journal, where he is a senior editor, as well as Progress in Nuclear Energy Journal and Construction Management and Economics. So Giorgio, welcome. It is really a pleasure to be here, opening our series, and the floor is yours.
Thank you very much, Elias, for the invitation. It's a great pleasure and great honor to be here today. I'm very grateful also to UCL and Bartlett School of Sustainable Construction for the opportunity to be here and speak to this very respected audience. So the topic of today is modularizing mega project for replicability, and we are going to look at an example. We're looking to do a peculiar case study that is the nuclear industry, because it's an industry that I'm very familiar with, and I think is very relevant for the UK, but more in general across Europe and the world in this moment. So, okay, a brief agenda. We'll have two main sections. One of problem setting. This is mostly a review of literature review study about nuclear power as a mega project. We are going to discuss the performance and the sense making. And then I want to be a bit provocative. I would like to discuss a problem solving, and I left a kind of question marker there, and the role of modularization in this. So we discussed two ideas that people might confuse, modularization and modularity, that are two radically different things, and the role that small modular reactors can play in order to make, let's say, nuclear mega project less mega project, and some key message for people to take home. So let me start from the reality. So what is out there? What is out there is that when we discuss about a nuclear power plant, particularly in Europe and North America, we have a very poor project management performance. Those mega projects, because they are project costing 5 to 10 billion each for each reactor, are frequently over budget and late. These apply to various reactors, various technology, and in different countries, Flamanville in France, the UK, Slovak Republic, United States, and so far and so forth. This is not a news. So this is a table from the Congressional Budget Office of the United States, the table from 1986, where show the project performance of nuclear power plant construction in the USA during the 60s and the 70s, when the bulk of nuclear reactor there has been built. And as you can see, the actual cost were 3 times as much the budget cost. So the idea that nuclear power projects are over budget and late is not something new, is not something that is unheard. So when we discuss nuclear power plant, it's a kind of always a nightmare. So there is this technology that in theory is very nice, it's very green, can produce a lot of electricity, but there is this nightmare story about the project performance. Now, when I start to work on this, I ask myself, what's wrong with this technology? And I start to look around, and I found an interesting case. That is the case of South Korea. So South Korea didn't have nuclear power originally. And in the 70s, they decided to develop a nuclear fleet, importing technology from the US mostly. So they were asking people that were so poor in performance in their country to come to their country to build a nuclear reactor there. What happened empirically is that in South Korea, the project performance was much better. Now, when we discussed cost performance, it's always a challenge to understand which are the true data, because we have to update for cost versus price, contingency, inflation. So I prefer to use the construction time, and we know the construction time of each reactor in the world. That data is publicly available because it's available from the International Atomic Energy Agency. So in this graph, I plotted the construction time of a Korean nuclear power plant. And as you can see, they are able to build a nuclear power plant in less than 5 years, large nuclear power plant. How they did that? Through replicability. So they got the same idea, the same reactor design that has been replicated over and over and over. So this is an interesting idea. And I started to look at this between 10, 15 years ago. And so I realized that project management is quite important. And the way that you plan and deliver your project is very important. So I started to get passionate about mega projects and see what we can learn from them. So some literature. If you are interested particularly in the energy sector like I am, I suggest you a few papers. There is this researcher, Benjamin Savako, is very good. And you have this database of projects, and it showed that there are 400 power plants transmission and only 10% experience no cost overrun. So 90% is over budget and late. Hydroelectric dams and nuclear reactor are the most frequent and the most over budget, both in absolute and relative terms. And he found something super interesting. So he ran a statistical analysis of this, and he identified that when you go bigger, more likely you will be over budget, and bigger is going to be over budget. When you go small, less likely you're going to be over budget, and smaller is going to be over budget in relative and absolute terms. So these three papers are truly, truly interesting on that regard. And then there is the idea of fragility, the idea that when you go big, things become so unique that it's very hard to correct the project when things start to go wrong. I always make an example of turbine. Large reactor have a turbine of 1.4, 1.6 gigawatt, and there are in the world maybe 1-2 suppliers for that kind of turbine. If one of those suppliers get in trouble, your project is in trouble. Small reactor, like we are going to discuss later, are 50, 100 megawatt, 200 megawatt, depending on design reactor. So the turbine is something more common and off the shelf. The project is less fragile. But why is so frequent that mega projects are over budget and late? This is an excellent question that has been discussed in tons of paper. Okay. Now, if you're doing a PhD on this topic, read this paper. Okay, they're interesting, very important. If you're not doing a PhD on this topic, you can read just one paper, because lucky for you, we had three excellent researchers, Giuliano, Andy, and Elias, that wrote this excellent, very truly excellent systematic literature review where they discuss cause and cure for poor mega project performance. So I wanted to nibble a bit on this literature, and I want to nibble a bit on this paper, just flagging out some idea that help us to set the problem. So why mega projects are so over budget and late? Well, we know the idea of optimism bias, the idea that proponent see this project in a very favorable way, are very optimistic, and so they think only the bright side of the project. They cannot see the risk, they can struggle to see the downside. So this is genuinely optimism, it's not intentional. The other one is a strategic misrepresentation, and this is intentional, okay? So you are misrepresenting reality because you want to sell your project. Now, you might recognize here a burger. This is what you can see when you go to McDonald's or Burger King. You go and you watch the advertisement and you watch the things, you say, oh, that's very nice, very juicy burger. What you get, so you pay, but what you get is usually something like that, okay? Not so nice, not so juicy, probably not the best quality stuff. Do McDonald's know or Burger King know that you're getting what is on the right? Yes, they know. They perfectly know that this is what they deliver, but this is what they picture to you in order to sell you the project. This is intentional, this is strategic misrepresentation. Now, so why are for instance, the European pressurized reactor in France and failed over budget and late? If you look at the construction time of nuclear power plant in France there are 59 nuclear reactors. This is pretty clear. So in France, during the 1885, they built a 4 cluster of power plant of about 150 megawatt. It took about 60, 72 months. Then they made the reactor bigger. They did a second cluster of 1350, and the duration became 96 months. Then they built some reactors even bigger, 1550. That was in the 2000 when this was commissioned, and the duration was about 10 years. Now, when they have to sell the reactor to Finland, they came up with a reactor that is even bigger, 1650. They lost capabilities because a lot of time passed, and they said, we can deliver this in 5 years. So clearly, this is not realistic. And I really like to say that this is, I told you so moment, because in the 2011, I wrote this paper, published in 2012, where I was looking at the technology of EPR, also of N4 and Convoy, that are the 2 designs used to make this reactor, and how the historical data on construction are totally far away from the forecast. Okay? So this is one component, is optimism and strategic misrepresentation in action, if you like. But also there is mistakes in construction. So this is something that in the USA has been terrible. So they designed this nuclear reactor. The design maybe was great. They have perfect engineers, but when they went to the construction site, they have a poorly trained workforce. So they were doing weldings, they were pouring a concrete. Then there was the inspector coming and found non-conformities. So that was a mistake that need to be corrected. Now, we think that this is something in the 70s and the 80s, but if you follow a bit the story of EPR in France, and these are news from public news from World Nuclear News from 2018, 2019, you found that they struggle a lot with quality. So this in particular is a story that went on for a couple of years about welding in the primary and secondary circuit, that most of these welding have to be redone. And those are weldings that are huge, so big like rooms, those pipes, so 2-3 meters of diameter sometimes. And these are super expensive to fix, and that takes a month to fix. This explains the delay. This further explains the over budget. Very interesting story. Check this out in World Nuclear News. Then there is the scope change. So we got episode like Fukushima. And so we went to something like this Fiat Panda, to this Ferrari. So yes, it's still red. Yes, there are still 4 wheels, but the 2 things are not quite the same. So when we discussed cost overrun, particularly nuclear, we need to be super careful, because what we have originally in mind as a plan and what we deliver might be very different. So we should distinguish, and this is true in general, between cost overrun and cost growth. So let's say that to build this kind of house cost 100 pounds. To build this second house cost 200 pounds. Okay. Now you plan to build this cheap house, and your budget was 100 pounds, but you end up spending 200 pounds. The big question that I always ask is, but what did you deliver at the end for 200 pounds? Because if you planned this for 100 and you deliver this for 200, you have a cost overrun and cost growth, okay? But if you plan this for 100 and you deliver this for 200, you might have cost growth, but you don't have a cost overrun, because what you deliver is different from what you planned. So the cost increased, but also the benefit. Then there are the idea of poor risk management. This is something that we observe like in Olkiluoto when they ask a supplier to build with fixed cost contract to be the base lab, so the foundation of the reactor, and they have a huge not conformities. And there are escalation of commitment. So there is this paper from 1993, is an excellent paper on academic management, one of my favorite, discussing the escalation of commitment in the construction of a nuclear reactor near New York. And the cost for that plant, this table is from that paper, went from roughly 65, 70 million to 5.5 billion. So this was a 20-year project. And the idea is that because of escalation of commitment, the company that was building this reactor, the utility, got stuck in this terrible situation where they cannot leave the project because that would bankrupt the utility. The financier bank were so invested in this that don't give them money anymore, means not delivering the project. The people involved were a bunch of nuclear engineers that love nuclear power plants, so they love to go on with building a nuclear power plant, and so far and so forth. So again, it's something not new, it's something that is there. These huge, huge power plant, very expensive power plant, are prone to all these issues. So tons of paper, tons of idea on this. And let me put everything in one slide. So large nuclear projects are truly mega projects, okay? So all mega projects are prone to optimism, bias, strategic misrepresentation, and so far and so forth. But nuclear reactors have another layer that is the complexity, because they are super, super complex machines with a lot of different science and discipline involved. And they have to be delivered to the highest quality, because we are discussing about a technology that is potentially extremely, extremely dangerous, far more than a bridge. If a bridge collapses, might kill people on that. I'm sorry for them, but that's the end of the story. If the nuclear reactor, there is a leakage of radioactivity or an explosion, even if they cannot explode, that might ruin an area for thousands of years. So this make the quality far the key driver. So there is the idea that we have a first of a kind technology that are tried, and the complexity of technology. So these are peculiarity of nuclear reactor, and also organization. We have organization that sometimes never built a nuclear power plant before, and they behave like these kids in the kindergarten. They try to do it, probably not with the biggest success. So what we can do to address all these issues? Yes, this is truly a brain teaser. Well, we can use data. So if we use historical data to estimate the construction time and cost of the EPA in France, probably we can become better in scope management. Okay, it is astonishing to see how the scope, not because the owner wanted, maybe, but because the, for instance, the safety authority asked for those change. Plan, this is a cure that is being suggested. So to have someone that check your plan. I mean, there are organizations that can do this for you, like ITA, Independent Project Analysis. They come to check your project. There is the idea of benchmarking. Bias, like in the green, and so on. I think that we have a basic issue. This is probably the most important slide in my presentation. We are treating the symptoms rather than addressing the cause. So the symptom is the project is late, the project is over budget. The immediate complexity is a uniqueness, are distorted incentives. So to put a budget uplift can fix the project is over budget because I start with a cost estimation that is higher in the place, but I'm curing the symptom, not the cause. So I think that there is a misunderstanding about scale. And this is probably the behind scale, with the idea that something bigger, unitary cost that is cheaper. That's why, by the way, nuclear power plant increased in size over the year. They start to go to 600, 800, 1,000, 1,600. So the idea is that something bigger is cheaper. Why? Well, because of a number of reasons. The idea that you have a pipe, if you make a double pipe, you have double diameter, so double circumference, so double cost. Check it out, go to the side. However, double diameter means 4 times as much area, so 4 times as much flow, 4 times as much power, so half a unitary cost for unit of power. Geometrical reason. These apply to pipes, these apply to pressure vessel, these apply to all things. Fixed and semi-fixed cost, licensing side cost, front end, personnel, bulk ordering, and so far and so forth. Now, the idea of economy of scale is true only to a certain extent, because this idea of a pipe, that bigger pipe is unitary cheaper, is true only if when you are in a commercial range. Because if I told you, you got the BMQ, that's rule apply because everything there is commercial. But when you start to make it bigger and bigger and bigger, needed to be custom made, you go bigger, bigger and bigger, the number of suppliers decrease. At the end, maybe you are stuck with one supplier, and that supplier can ask you whatever the price they want. So the misunderstanding about economy of scale is that, yes, you start decreasing, but at a certain point, the unitary costs start to increase again, and you get into this white elephant range. So when we discuss something like a nuclear power plant, you cannot go too small, this economy of scale, and you cannot go too big because you get stuck in the white elephant. What we know is the economy of multiples. The idea that when you do something, the same output becomes cheaper and cheaper. This is something that has been widely studied over the last 100 years. This is why today wind farm cost, the cost of wind farm decreased, the cost of solar plant decreased, the cost of aircraft construction decreased, because we do many of them and we have a learning process. So where is it coming to this? Modularization is a key enabler. Now, let's think about this. You can have a monolithic plant stick built, and you can chop this monolithic plant in. You still have one plant in modules, and we call this modularization. Or you can do like the Koreans. The Koreans get this plant, and they replicate the same plant over and over and over, the standardization. But what about if you get this plant, you chop it down in smaller plants that use modularization? You get what we call modularity. The idea that you go, instead of doing one big, you do 4 identical small that use modularization. That's modularity. And that is what things get interesting. So we know the modularization. We have plenty of study discussing the cost saving, the schedule reduction, and so far and so forth. We know that we use that when we want to build in place that construction costs in the site are very high. So the key idea of modularization is moving construction cost from site to factory. However, what we usually forget is the powerful idea of standardization. This is what I told you before in the Korean case, the idea that keep building the same reactor over and over and over, decrease the cost. So let's put this idea together. So we can have standardization that are physical. Coca-Cola is an example, okay? It's always the same things delivered over and over and over. But standardization is not just physical. It's the standardization of the project delivery chain. So the same stakeholder that always come together to do the project. So when we look at this case of Korean, here they standardized the product, so the designer of the reactor, but they also standardize the project organization. The supplier of the turbine is always the same. The supplier of the heat exchanger is always the same. The construction company is always the same. The utility is one. The safety authority is always looking to the same reactor. Think how easy things become. So modularization plus standardization equal modularity. And this is how we manage to decrease the cost of everyday object. Think about a car. At the end, what is the great idea of Ford? To standardize and to have standard components to put in. Look at the aircraft, the same aircraft produced over and over. Look at your mobile phone. Maybe the same chip in your mobile phone is used in many other phones. Your phone is cost maybe 150. My one cost like 300 euro because they build millions of them. I have an interesting case study. Nobody ever built SMR. So let me use the other sector that is safety critical. That is the aerospace sector. Think about Ryanair, okay? So Ryanair have airport all over Europe. And let's say that you want to go from London, where there is Elias. Elias wants to come to visit me. So Elias now is in London and I'm in Milano Bergamo. And Elias wants to take the flight to come to visit me. How much is the cost of this flight? Is around £25. Okay, the standard fare is around £25, and there are 4 flights a day. Now think about this: 4 flights a day. Why they don't do 1 flight bigger? So the idea is that the Ryanair has a fleet of 357 aircraft that are absolutely identical. They have 1 single type of aircraft. And they tell you this. That's their website. Our policy of using 737-800 exclusively is part of our strategy to bring you the cheapest flight. Think how easy is the maintenance of these aircraft. How easy is the training of operator? How easy is upgrade, for instance, of a software? Think when they have to buy 20 more. They go to Boeing and say, hey, I need 20 more. They are off the shelf. That's what drove down the cost. And I really like this graph. Please look at the size of the plane, so the number of passengers, and the range. Now, the plane is small. Okay? The number of passengers is small, it's 170 about. So why they don't use this plane here to go to Milan? Okay? They would save money in theory, according to economy of scale. They have just 2 flights a day instead of 4. No, they make 4 because they standardized everything. Okay? And that's why they can keep the cost down. They can keep this generate profit over the years. And they don't bring it to Milan, but even a nicer city, that is my city, that is Bergamo. What about risk? So when we build a nuclear reactor, regardless if it is small or large, we have a risk. We have a first of a kind cost that are unknown. We have exogenous risk, exchange rate, think about Brexit, interest escalation, like nowadays, legislation change because of Chernobyl, external event like COVID, or endogenous, design mistake, supplier mistake, mistake in construction. These things apply to large and small, of course. What is radically different is the scale. So the first of a kind costs are unknown, true, but the scale is different. So if you're building 1 large reactor, you are, let me say, gambling 10 billion. If you're building a small modular reactor, you're gambling 2 billion. Doubling the cost on 10 billion is 10 extra billion. A doubling cost on 2 billion is 2 billion. The scale is totally different. Exogenous, yes, but the construction of a power plant, of a smaller power plant, is much shorter. And since it's smaller, you can increase the amount of modularization. Endogenous mistake. Yes, it's true. On the first SMR, it's going to be a mess. But what is better, to learn and to make a mess on a 10 billion infrastructure, on a 2 billion infrastructure. So it's better to learn something that is cheap than expensive. So after 1, 2, 3 units, you now perfectly know what you're doing, and you can be consistent every time that you want to deliver something. So this is why I say that we need to treat the problem. So the symptoms of nuclear power plant construction is late, over budget. The problem is complexity, is the idea that every time you do a unique infrastructure with a unique set of stakeholders, are the distorted incentives that tell you, hey, I will sell you this reactor, it's going to be on time, on budget, it's going to be cheap, and that's not true. So what? We can put in place many different things like benchmarking previous project, start from a completed design. This is one of the key problems in the nuclear industry. We start construction without a completed design, so we have to do a lot of change. Develop stakeholder accountability, foster economy of multiples. Now, when we look at this and we look at standalone the large reactor, it's very hard to benchmark. Most of the time I start the construction without a previous design. It's hard to develop stakeholder accountability, and I'm not fostering economy of multiples. But if I make several right small modular reactor, I can do benchmarking. After the first units, the second units will have a design that is completed and checked by the safety authority. That is not trivial. I can develop accountability. I sell 4 reactors with the condition that I will get the second, third, and fourth units only if the first unit is delivered between a reasonable time and budget. So I cannot overpromise. And I can foster economy of multiples, the idea that I have more learning. And then there is here the big question, the economy of scale. You don't have to be too small or too big. So I believe at the end that the nuclear business works in this way. So you go too small, you have the issue of this economy of scale, too many fixed costs, geometrical reason. You go too big, the project is fragile, the project is unique, you cannot lurch. So SMR foster accountability, they are less complex because a number of technical solutions become available when you go small. You can foster learning and you can have a better risk management. Large reactor, they have world experience, nobody ever built SMR before, and they have economy of scale on their side. I want to leave with one last concept, that we often confuse something complicated with complex. So a clock is complicated. Okay? It's full of gear, it's full of things, but there are linear relationships with predictable outcome. A well-designed clock can go on for years, and we know exactly what is going to happen in that clock 1 hour from now, 1 day from now. What is complex is the weather. There are causal loops, super complex with unpredictable outcomes. We started nuclear power that were complicated, and we made it complex. We needed to go back from complex to complicated machine. As engineer, we can deal with complicated machine. Your mobile phone is a super complicated machine, still is very reliable, still is very cheap to do. Something complex is a mess. Key message, large engineering projects are often delivered over budget and late, tons of literature here. If you have to read one paper only, read that paper that I suggested you. Larger the project, more likely to encounter delivery issue. Again, that's fact, strong literature here. I believe that most of people is try to treat the symptoms rather than addressing the cause. To do a budget uplift at the beginning is a way to increase the original budget, so you hide an overrun because you start with a higher budget, but you are treating the symptom, not the cause. Small modular reactor can truly exploit the economy of multiples and break down a mega project in more regular project. After the first, you can have a complete design. So you eliminate a lot of unknown, you eliminate a lot of rework. You can have the standardization of design your supply chain. You can develop stakeholder accountability, telling that you build the second only if the first is good. You can reduce complexity. You can make, in general, a mega project less mega. I don't have time to speak about project ecologies, but the right size of a small modular reactor or a large reactor is also influenced by the country situation. And to deliver several small modular reactors can be an approach to deliver good project management performance. at least in a country like in the UK. This is what I wanted to say. Thank you very much for listening, and I'm very keen to take a question and discuss with you about this idea.
Thank you so much, Gio. That was very informative and very intriguing. So now we have, we could use the rest of our time to ask questions. Don't forget, you can always use the Q&A function on Zoom, which is shown down below. We already have one question by Ian, but you can also ask questions straight to Gio. Just simply unmute yourself, and then we can have a discussion. So, should we, Gio? Should we answer the? We have a couple of questions in the Q&A, so we can start from that if you like.
I start from the first. Is from Ian. Sorry for the Teamstall. Apologies if I misread. Have you identified any other life cycle improvement from using smaller module? Maybe this is different between batch and continuous process, but I found by using smaller units times, I need less capacity in total to meet the business model. Yes, the straight answer is yes. Smaller units are not only convenient in construction, they are also convenient in operation. And I give you an example. So one of the big deal is a backup capacity. So let's say that you have a large reactor like the EPR that is 1.6 gigawatt. That's about 3-4% of the UK capacity. And let's say that for some reason you have to shut it down. There is a temperature that is too high, a pressure that is too low, a valves that give you some signal. That's called unplanned outage. That happens quite often in the nuclear industry. No big deal. Usually is an easy fix, 99.99% of the time. But you shut down the reactor. This means that somewhere you need to find the backup capacity for that reactor. That backup capacity needs to be booked, and that's expensive. Not only, that backup capacity cannot come from the other side of the country because the electrical line can only transmit a certain amount of power. So need to be reasonably local. And that is an expensive thing to have. This is just an example. Another one is the idea of spare part. If you have many reactors that are identical, you don't need a large spare part sitting in your warehouse waiting for them to be used. And that's a cost that is there. But you can have smaller spare capacity that are shared between the units and can be used when there is something going wrong.
Okay, perfect. There's another question by Tausif. I can read it if you like. Interesting presentation. Do you think the same philosophy can also be used for infrastructure projects, for example, bridges or tunnels that are both unique and large?
That's not sure. Probably not for that. I cannot see this for a bridge or a tunnel, probably.
I was thinking about that too. I was thinking whether we could use the same philosophy, the same principles that in the case that you described for railways, and the case of replication will be very different because it's linear infrastructure as opposed to.
Well, in China they replicated the technology of railway. So the idea that they develop a certain technology, certain system that are used more widely. So that's definitely, there is something in the replication. I'm sure that there is an economy of scale in railway as well. There is another question, Tommy.
Yes, but Tommy.
Did you mention the physics of nuclear reactor? There is a minimum size of the reactor for it to work. How much is that? No, there isn't. Nuclear power plant goes from like 2-3 megawatt for megawatt to 1,600. So no, there is no such things. Even if when we go small, we try to use a different kind of technology. Ata, bye-bye. As you mentioned, when the practice is standardized, many practices are already developed, so at least there is somehow clear how the process looks like. Yes. What is the role of the front end in standardized project? Is there a difference between a standardized project and a conventional one? Well, yeah, that's a beautiful question. The idea is that when you are replicating, the front end design is already been done. So you pay for it only once. Not only the front end design, but also the detailed design. You can try as much as possible to copy and paste. Antonius, where academics try to reduce mega projects in terms of its size and start from smaller projects, are we surrounded to cure the causes of mega project, poor performance, especially its uncertainty? So why academics try to reduce mega project in terms of its size and start from smaller? Okay, so we started actually from smaller project in the nuclear industry, but people believed so much in the economy scale that they start to go big. But many other people believe that we went too big. So at the beginning, we observed a benefit with the economy of scale because at the beginning, the costs decreased because of the economy of scale. But then we went totally off scale and we went up. There was a tweet from Hinkley Point account where they were saying, oh, look at us, we are using the biggest crane in Europe is here in our site to build the APR reactor. And they were kind of bragging about this, feeling them so proud. And I'm not a nice person. And I sent the tweet saying, you should be ashamed of that. That's not something to be proud of. This is something you need such a large crane. You should be proud to say, I'm using a regular off-the-shelf crane to build my nuclear power plant, because my nuclear power plant is so easy to build, so conventional, so boring, that I can use any kind of crane. But the engineering mind, and there was this call sometimes ago about Sublime in a mega project. We love stuff that is unique. We love stuff that is big. And if you speak with people in investment banking, and I did that a lot of time, they hate that. It's super fascinating to speak with people in investment banking. They want something that is proven, something that is boring, something that is off the shelf, something that you plug in and makes money. That's not what engineers love. Ian, how do you manage the dilemma, the standardization push against continuous improvement? How do you judge when to keep the same and want to update your technology? Well, yeah, standardization is kind of against continuous improvement. Look at aircraft, okay? They make 300 aircraft every time, 300, 500 aircraft every time that they make a new aircraft. So as engineers, we always try to make things new, make things interesting, make things. But actually, those bunch of reactors built in the 80s, they are working perfectly fine. There is nothing wrong with them. Okay, so again, to increase maybe the efficiency by 1%, we make a construction cost 30% more. And we create a sort of risk in unknown, changing the design, that is not worth. And that's really what is from what we can learn from the aerospace industry. Giacomo Dai, do you think that increasing modularity there could be risk of having the company owning design gain a monopolistic position? Other excellent question. Yes, and that's something that is widely discussed at an international level. So let's say that you develop a nuclear reactor in the UK, and you go to another country, country B, and country B say, hey, I like your reactor, but this reactor should be built with my companies because I want to create jobs and capabilities in my country. That goes a bit against the idea of standardization, at least in the supply chain. So yes, there is this risk. What is usually suggested is that in the nuclear reactor, there are three main elements. The nuclear island, where there is the nuclear reactor with the control rod, heat exchanger, pressurized, so the super nuclear stuff. The conventional island, where we have the turbine, where we have the electrical system, what we call balance of plant, that is quite conventional. And then there is the civil work, so concrete. That account, the civil work, they account about 1/3 each, roughly. The idea is that the nuclear island should be monopolistic, should be made in a certain country, in a certain factory that have the right capability, the right specification to make that. The other element, the conventional island, and the civil work can be done locally. So the monopolistic bit will be only 1/3.
Great. Doesn't seem like. Does anyone else has any more questions that they would like to ask Gio? Okay, well, whilst we wait, Gio, I have a question. So why haven't policymakers and governments worldwide adopted this approach and instead are going always for the mega projects with regards to nuclear power plants?
Well, many governments nowadays are interested in small modular reactor. One example is the UK government, just to make an example. But in country like the UK, is not the government that buys nuclear power plant. There is no state-owned utility in the UK, not in the United States. There are countries where utility are owned by the state. Okay, France, Electricité de France, that is the biggest utility, is basically 75%, something like that, controlled directly or indirectly by the French government. I work a lot with the International Atomic Energy Agency and the opportunity to speak with a lot of policymakers. They love the idea of small modular reactor, but they have one problem with that. That is, I don't want to be the first. So they say, look, Rolls-Royce or Chinese people or Korean or whatever it is, they're designing this nuclear reactor, build one, show me that you can do this as promised, and operate this a couple of years, show me that the reactor is reliable. By what is happening now in China. So in China, they're building the first small modular reactor just as a demonstration. It's a 100 megawatt, is peanuts for China. But they do this as a demonstration. So they want to show the world that they can build that reactor in time and cost as expected. So when there is another government, they can go to China, they can see the reactor, they can see the safety feature, they can see the performance, and they can bring in their own country.
Thank you. Oh, we have another question in the meantime by Antonius. What's your opinion about successful mega projects? Is it a coincidence or achievement?
Quite. So when I presented, I was careful to use the expression project management performance. So what we discussed in the project management community in the last 20 years is that we needed to distinguish the performance of doing the project, so the cost, time, and quality performance, with the long-term cost and benefit of the project. So let's go back to the United States nuclear power plant. So yes, they've been, and I told you at the very beginning that this power plant has been delivered 3 times as much as a cost. Now, okay. However, today, those power plants are extremely valuable asset. They can produce a lot of reliable electricity. They produce very cheap electricity. They produce electricity without making any CO2 emission. So the long-term benefit to compare budget cost with actual cost is a discussion about project management performance. To compare actual cost with actual benefit, that's a discussion of project performance. And in this case, the situation is very different. And I can ask you a provocative question. Think about the mega project in your country or in the UK, if you are in the UK. Think about which of these would you erase if you could go back in history? Even those over budget and late, would you erase them? Most of the time you will say no. Vedran, what is the relationship between scale of the project and its outcome? Strike me that some extremely large mega project can be very low impact in terms of looks like when we focus on the outcome rather than the output? Should we not be talking more about scale of impact rather than the scale of cost and output of the project? Pedro, that's a fantastic question. Thank you very much. What we know with modularity is exactly this. And this is something, a point, and I'm very glad to have this question. Right, okay, yeah. So when we do pure modularization only changes the construction way. So what we get here, or what we got here, once the construction is over, is practically the same. There is no real difference. So long term, it's mostly irrelevant that you have a modularization or a stick-built plant. The interesting bit is on modularity. Because when you go from one large to 4 small that are modular, you have a lot of interesting degree of freedom that are opening up. For instance, if this is small, it's much easier to do cogeneration. You can use these smaller units for district heating. Since they are 4 and they are small and are identical, they can share spare part. They can be the backup one of the other. That's amazing. So if you have this plant only and you shut down, you have to replace the capacity of this one. But if you have a 4 and you shut down one, you can increase the power of the other 3 a bit maybe and cover automatically. So when modularization alone, I would say there is no difference. Modularity is a game changer. With modularity, are we shifting it a bit from project management toward combination with product management? Yeah, probably yes, because we're going toward a standardized product. Instead of having the white elephant, instead of having the airport that is unique, we are going toward the airplane model. So for me, but not just for me, for a bunch of people in the nuclear industry, we should look again to the aircraft industry. The same airplane built as a with a modular approach 200, 300 times. That's why airplanes today are so cheap, it's so easy to travel, they are so reliable, so safe, because they are as much as possible identical. It's what Ryanair teach us, it's what low-cost flight teach us.
Brilliant. And I don't see any more questions. I have a quick question before we go. What would the architects say about this, this approach of standardization? Because I'm thinking about there is vanity in the projects that we make, both from a client point of view, but also from an engineer and a designer point of view. So that's why we want something, we want to put ourselves in these projects. And with that level of standardization, there is a limitation in terms of creativity.
This is true, is a price that we have to pay. So in my first lecture in Politecnico, when I teach my student, I tell them to read this paper, and I want the audience, maybe they can consider this. So first lecture, suggested reading, this one. So this is called, it's a paper in energy policy published in 2009. It's called Learn from the Successful Program of but they do so, and they tell you about this idea, that they stopped engineers to design and say, look, dear engineer, you don't have to make the design, you don't have to increase the efficiency by 1%, completely. Your best effort should be on constructability. Your best effort should be on defining the design. The design that is beautiful is the design that is simple and easy to build. So they were not going modular, absolutely not. They were focusing on constructivity. And the things. And one of the key idea where is it? Here, continuous feedback and review by internal and external. Continuous feedback from construction. Clear definition of responsibility, and so far and so forth. So yes, I'm an engineer. I started with these ideas. I'm a mechanical engineer. I started my career because I want to design the engine of Ferrari like everyone. But at the end, we need to remember that as engineer, we are there to serve people. We love to mess around, something that's unique, but that's not what we should be allowed to do. We should be allowed to do something that's working, something that is sustainable, something that is easy to build, something that provides long-term cost and benefit for the environment, for the people. That's what we need to learn.
Beautifully said. And with this message, I would like to thank you, Gio, for this amazing presentation. And thanks to the audience for asking all these questions and sharing their thoughts. We have reached the end of this session, but we have more sessions and speakers. So stay tuned with us and have a nice rest of the day. Thank you all. Bye-bye.